How's it going, everybody? In this video, we're going to be going ahead and taking a look at rolling out inter-AS option C in our deployment. We're going to be using the redistribution method in this particular set of videos, where we're going to redistribute any of the BGP learned routes from the ASBRs through their propagation into IGP so that LDP will allocate labels. We're going to do that in this video, and then in the following video, we'll switch gears to labeled unicast. So let's go ahead and dive in. So one of the first things we have to do is on CSR5 and CSR6, as well as the ASBRs, we need to basically set up a connectivity between the ASBRs for labeled unicast. So that's the first thing I'm going to go do. Type in router BGP1. We'll do the address family IPv4 unicast, and then neighbor of 12.5.6.6. activate, and then send label. We're going to go over to CSR6, do the same thing. Router BGP2, address family IPv4 unicast, neighbor of 12.5.6.5, and activate, and then send label. And there we have it. So that'll form an adjacency via IPv4 unicast. But now we need to go actually propagate routes. So there's one or two different ways you can do this. The first way would be to go onto each and individual device and turn the address family IPv4 unicast on, and then allocate the routes locally. So CSR1 would allocate itself, CSR2 would do itself, route reflector 1 would do itself, XRV11 would do itself, etc. Or we do it on the ASBRs, or typically any other box in the network would be sufficient. So I'm going to go, and before we can really do that and actually make it work, the ASBRs and the route reflectors, we must turn on the IPv4 unicast connectivity in order for it to actually propagate the routing information and get all that stuff squared away. So we're going to go and enable the IPv4 unicast BGP peering so that the routing information can get in this case here, in order for the route propagation to work, we need to advertise prefixes. So one side will do it on one way and the other side will do it on the other. In other words, on AS1, we will advertise the routes on the ASBR. So we'll get that done. And on CSR6, on the AS2, we'll go through and we will form IPv4 unicast peerings, which will allow the individual nodes to advertise their own information. We'll go do that. So on CSR5, for example, here, if I do show IP route, you'll see that I have a bunch of loopback information in here. So I have like all the loopbacks of all the routers in the network. I need to go ahead and type in here network of 1.0.0.1 mask /32. Same thing for CSR2, and then I need to go do 101 for the route reflector. So CSR6, if I do show IP BGP summary, I should be learning prefixes, which is going to be the loopback of CSR1. So we should start to learn more prefixes, and we are. So that's a good sign. So then I'm going to go to XRV11 and 12 and get him squared away. So we'll go to Rob and Cisco. We'll log in. Go to global config. And we're not going to use IPv4 unicast. We're going to use address family IPv4 labeled unicast. So let's take a look at that. We'll type in router BGP1, address family IPv4, and then there is unicast, right? Well, the thing to remember here is when we're doing this configuration, when we go to do a neighbor of 12.11.12.12 and we type in address family IPv4, we have the option of labeled unicast right here. So we're going to use that and hit the enter key. And then we're going to type in the route-policy for eBGP peers in and out. And we're going to go ahead and commit that. And then I will go under 12 and do the same thing. Rob and Cisco, go to global config, router BGP2, address family IPv4 unicast, and then neighbor of 12.11.12.11, address family IPv4 labeled unicast, and then route dash policy of RPL eBGP peer in and out. Now that I've done that, I can go back to address family IPv4 unicast, and on this side I'm not actually going to go and do the additional config where I'm not going to form the peerings just yet. What I will do is on XRP11 is I'll type in the address family IPv4 unicast and then the network statement of 1.0.0.1/32, 2/32, and then 101/32. And I'm going to go ahead and commit all this so that what will end up happening is do show BGP IPv4 unicast. We'll start to learn, IPv4 labeled unicast. None of the requested address family IPv4 unicast. Yeah, that should be there. Do show run router BGP. So I should have peering to let's see here. Did it not take? Oh, you know what? I may not have a neighbor. No, I have it right here. This guy here. And then remote AS of 1. Address family IPv4 labeled unicast. Route dash policy of RPL eBGP peer in and out, commit, and then let's make sure it's working here. Do show run router BGP, and yeah, for whatever reason it's not working here. Oh, okay, there we go. So I must have done something with the configuration. So now if I go back to 12 and I do show BGP IPv4 labeled unicast summary, let me just double check on 11. Do show run router BGP. I should be propagating routes, which I am. If we do show run router BGP, and let's scroll through the configuration real quick. So I have labeled unicast configured, which is good. And let me look at 12 again. I should be receiving routes, which I am not. Oh, you know what I probably have to do? On XR11, this is one thing that I forgot to mention earlier. When you do this, you need to, on XR specifically, you need to go underneath address family IPv4 unicast and turn the command on allocate label all. And what that's basically going to do is with the iOS boxes, when you type in the address family IPv4 unicast and you activate the peering and then you send label, it's automatically turning on labeling, which means you're going to advertise BGP labels. With XR, you have to do the allocate label all so that it will allocate labels for anything that you bring across. Because right now it's like, well, I don't know what to do with this stuff. So if I type this command in here and then do a show config, and I grab this config right here, I jump over to 11, do the same thing, and then commit, and commit here, and then do show BGP, VPN, or IPv4 labeled unicast. I'm now learning routes. So that's what was missing before. So now I've got the route propagation happening. Now on AS2, I'm going to change it up a little bit, where I'm going to go to route reflector 2 in this particular case here, and I'm going to do labeled unicast. So I'm technically jumping the gun a little bit. Normally you would do this on both sides, but you can do one AS one way and one AS another. So I'm going to do the redistribution in AS1 and the labeled unicast in AS2. So I could do redistribution in both, but it's, you know what? I think I will. Now that I'm thinking about it, I will continue to do the redistribution just so you guys can see both sides and how it'll affect, and I'll do a transition point. So that's what I'll do. I will just advertise the loopbacks on the ASBRs. I'll advertise them on the I'll advertise the route reflector and PE router loopbacks on the ASBRs. So let's go ahead and jump over to 12 again, and then we'll type in network of 2.0.0.8/32, 16, and then 20. And then we're going to go ahead and commit. And then on CSR6, we'll do the same thing. We'll type in network of 2.0.0.8 mask/32. We'll do 16 and then 20. And then what we'll end up getting on CSR5, if we do show BGP IPv4 unicast, we're now going to start learning those routes. So we've learned 8 already. Now what's going to end up happening is I need to look at what's happening from an operations perspective. So show BGP IPv4 unicast labels. And I am allocating labels for all this traffic. Right? So I have in labels, I also have an out label. So this is a BGP learned label. Now if I jump over to XRV11 and I show BGP IPv4 unicast labels, I'm going to have labels to get to 8, 16, and 20. I'm going to use labels 23, 24, and 25 respectively to this next hop. Right? All that stuff is working out. Now, in this particular case here, since I'm going to do redistribution into IGP on both sides, I'm going to go ahead and have to do that process now. And then that will allow me to allocate labels for everything. This is probably the easier of the two methods in order to make this work. And we'll talk about that here in just a second. So what I'll do is on CSR5, I'll go to global config and I'll go to router OSPF1 and I'll redistribute BGP1 subnets. I'll do that, and then on XR11 I'll do that. So router OSPF1 area 0 redistribute where is it? Redistribute, there we go. Redistribute BGP1, and then I need to specify the, yeah, that should be all I need to type in. Redistribute BGP1. I might need to do redistribute BGP1 no, I'm not. This isn't BGP into IGP, so I should be okay there. Now you technically could go into BGP and not advertise the routes via BGP, but you could redistribute routes from IGP into BGP and match on just the loopback addresses. So you could advertise everything. But in this case here, you really won't want to do that. It's actually cleaner to do the manual network advertisement that way instead of doing a redistribution of IGP into BGP, which is another option as well. So now if I go to, for example, route reflector 1 and I do a show MPLS forwarding table, I should see some entries in here for 8, 16, and 20, which I do, which means that redistribution of BGP learned routes on ASBR, on CSR5, the ASBR, into IGP to where the route reflector will learn that is working. CSR1 should see the same thing. So show MPLS forwarding table. I should have those routes learned from 16 and for 8, which is what I'm looking to see. Now what I'm going to go do is I'm going to do the same thing on 6 and 12. So underneath here we'll type in router ISIS1. I'll type in redistribute BGP 2 and level 2. And then on XR12, router ISIS1, redistribute or address family IPv4 unicast, redistribute BGP2 and level 2. Go ahead and commit that. And so now that I've done that, if I go to route reflector 2, log in here, and do a show MPLS forwarding table, I should have one route showing up, which is going to be 1, 2, and 101, which I do. So that means that's a good thing for me now, because now I have the connectivity to the place where it needs to be. Now, with the way that this is configured and the way this is working, I want to go and I now need to validate that I have end-to-end connectivity between 2 and 1. So that means on route reflector 2, if I do a ping to 1.0.0.101 sourcing from 2.0.0.20, I should be able to ping end-to-end. And I can't. Let's do it now. Let's do the same thing again, but let's do a trace route. And we'll do a trace numerically. And I use an MPLS. I use a label switch path to get there. That's a good thing, because now from route reflector 1 to route reflector 2, I'm following a label switch path, which means I should be able to do VPN-v4 peerings between the route reflectors. So let's go ahead and do that real quick. So let's go back. Let's go up here and type in router BGP2, and I'm gonna type in neighbor 1.0.0.101. I'm gonna type in it's the remote AS is 1. It's an eBGP multi-hop, so it doesn't really matter how many hops away it is. It's gonna default to 255. And for address family VPN-v4 unicast, I'm gonna type in the route policy here, and there is no one. There is no RPL here, so I'll type in RPL eBGP peer, and I'll say in and out, and then I'll just need to go to root and route dash policy of RPL eBGP peer. I'll say pass and then exit out and then commit. Now let me go over to route reflector 1 and do him. So global config router BGP1 neighbor of 2.0.0.20, and we're going to go and type in remote AS of 2, the eBGP multi-hop, and then address family VPN-v4 unicast, and then we're going to go ahead and activate it. Now that will form a VPN-v4 peering between the two, but it will take a couple of minutes for this to actually kick off and work. So keep that in mind. So once this forms, and notice how it's not working right away. We actually have to set the update source. So don't forget that. So we're going to exit out real quick, and we're going to hit the up arrow a few times, and I'm going to type in the update dash source is going to be loopback 0, and same thing on route reflector 2. So router BGP 2 neighbor of 1.0.0.101, and then update dash source is going to be loopback 0, and commit that. And there's the peering is now up. So if we look back at route reflector 1, I now have a BGP peering from that guy. So show BGP VPN-v4 unicast all. Show BGP VPN-v4 unicast all. I'm now learning routes from 2.20. Let's look at the summary. And I'm learning 6 routes from this guy. Right? So now now that I've got that in play, let's look at CSR1. So CSR1, if we were to do a show BGP VPN-v4 unicast all, I'm now learning a whole bunch of routes. But you'll notice the next hop is 2.20 or 2.0.0.20. And if I look at, say, CSR8 and show BGP VPN-v4 unicast all, you're going to see 101. 1.0.0.101 is my next hop. So what I'm going to go do now is I'm going to validate that 19 is learning routes. Show IP route. And we are learning prefixes from to 10.1.25. So now what I'm going to go do is a trace route to to 10.1.25.25, sourcing from loopback 0, I'm sorry, loopback 1 numerically, and you'll see that I actually have two different LSPs. The first LSP gets me through my autonomous system over the ASBR link, and then terminates me onto the interface of route reflector 2, which is why you notice the 24,023 terminates right there, and then another LSP kicks off and goes from route reflector 2 down to CSR8. So in order to fix this, we actually had to tell the route reflectors in each autonomous system for the VPN before peering between them to not set themselves as the next hop. So next hop unchanged. So on route reflector 1, we'll go to global config, router BGP 1, and we're going to type in address family VPN before unicast, and type in neighbor of 2.0.0.20, next hop unchanged. And do the same thing on route reflector 2. So here we're going to type in address family VPN before unicast, next hop unchanged, and commit that. So what will end up happening now when we go to look at this guy from this perspective, let's actually look at it from router A perspective. Come in here now, and what will end up happening is I'll need to actually trigger an update. So on route reflector 2, I'll do clear BGP VPN before unicast star soft to trigger the update, and the same thing at route reflector 1. Let's just double check to see if, there we go. So now they're updated. So now we see 2.0.0.8 and 2.0.0.16 is my next hops. So now if I go back to 19 and do that same trace route again, my trace route is now end-to-end. So I'm using label 38, 38, 38. It's one consistent label switch path. So there's that aspect of it. So that's using redistribution on the ASBRs. The major drawback to using redistribution on the ASBRs into IGP, so the LDP kicks in, traffic engineering really isn't supported here. So if you wanted to do advanced connectivity and do BGP-based traffic engineering, you're really not going to be able to, because in order for traffic to get to one of the ASBRs, it's going to use the IGP metric, or whatever the cost value is you get from CSR1 to either one of the ASBRs, because you're tying the label binding to IGP through the LDP propagation, because LDP is going to follow whatever connectivity is needed in order for IGP to get to it. So this method does work and it gets the job done. The drawback to it is that when you go through the process, you end up running into this problem. Traffic engineering gets very, very ugly in this particular case. So in the next video, we're going to undo the redistribution, and then we're going to go and on both autonomous systems, we're going to go push out IPv4 unicast peerings to everybody. So I'll explain how that will be a little bit different than what you previously seen. And the idea is when you go through this process, that when you get the connectivity up and running, you'll be able to tie the labeling to BGP. So you won't be redistributing BGP learned routes from the ASBR into IGP, where LDP will go in and kick off a label binding. You won't be doing that. You'll be using BGP labeling across the board end to end, which will mean a little bit more configuration, but it provides more scalability in terms of its operation. So we'll take a look at exactly how that works. There's a lot of BGP specifics that need to be considered with like next hop self and making sure you've got the right connectivity in play and that type of stuff. But we'll do labeled unicast on both sides and see exactly how that comes into play. I'm going to do one side first, and then we'll transition. We'll do some trace routes and see how that comes into play, so you can see, okay, we've seen redistribution on both sides. Then we'll transition one side to labeled unicast to see exactly how that works, and then we'll transition the other side and get that one up and running. That's my plan. So right now we have an end-to-end label switch path to get us from CSR1 to CSR8, and the connectivity works all day long. It's supported for IPv6 as well. I just haven't done the configuration. Because this requires more config, I'm going to break it out into individual examples. So when we do VPN v6, we'll take a look at that on its own separate video. So until next time, guys, thanks so much for stopping by and hanging out with me, and we'll catch you guys in the next video.